Today we're going to look over the review for Chapter 8 test, which is coming up, over sections 8.1, 8.2, and 8.4. So we're going to start out first. It says use a polar coordinate system to plot the point with the given polar coordinates. So I went ahead and made some separate graph paper to use. So we're just going to grab one of these. And the first one, we're going to use this graph right here. And it asks us to find -4, -3 pi over 4. Now remember we said polar coordinates r, theta. So this is our theta and this is our r. So now we're looking for where -3 pi over 4 is. Now as these are marked, this is going to be pi over 6. This is going to be pi over 4. This is going to be pi over 3, like our unit circle, right? So now when we look at it, we're going to decide where -3 pi over 4 is. So if I go pi over 4 down, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, right? So this would be -3 pi over 4, this line right here. So count it again. You're going negative direction, so you're going down. So 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, so I'm going to use a red marker on that then and show that that's the line that we stopped at, right? That red marker doesn't show very well, does it? Well, that's not much better, but that's a red marker. So we're going to take, and now we have to decide where's the point going to be. We found the theta, but now we've got to find the -4r. So when we take this line, when we stop there, that becomes the positive side. So if I extend it back on this, that would be the negative side. So we're going to go back 4. So we go 1, 2, 3, 4, and there would be my dot. That's all you have to do on number 1, that kind of thing. Okay, so let's look at number 2. We'll move it up and use the next graph down. So number 2 says to have 4, 9 pi over 4. 4, 9 pi over 4. Now 9 pi over 4 is not one of the ones that we have in the unit circle, but we can do what we did before. We're finding coterminals. So we're going to take 9 and divide by 4. 9 divided by 4 would be the fraction. It goes into there 2 times, which gives me 8. Subtract and get 1/4 pi. So I've got 2 and 1/4 pi. So 1 complete rotation is 2 pi, so we're going to subtract 2 pi, and then that's going to give me pi over 4. So my new ordered pair then is 4, pi over 4. 9 pi over 4 and pi over 4 are coterminal. So now we're going to ask ourselves, where is pi over 4? If this is 0, then this first line up here, right here, is going to be pi over 4. So I make that red so that you can see where we're talking about. If you can see the red. Now what is it doing? This is the positive side, right? So wherever we stop is the positive side. Back here would be the negative side. So in our case, it's a positive 4, so we count 1, 2, 3, 4, and there would be our dot. Okay? All right, we're going to do one more, and then we're going to leave the rest of them for on your own. So the next one for number 3 says we have 4, -5 pi over 4. Okay, so this first one was negative, negative, then we had positive, positive. Now we've got one is positive and one is negative. Okay, so we're going to look for where -5 pi over 4 is. So if we start here at the 0 and we go negative, it's going down, right? So -5 pi over 4. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. So this line right here is going to be our -5 pi over 4. You agree with that? -5 pi over 4. Now it kind of makes sense because you think about it. This is a pi, half the circle, right? Plus another fourth would be 5 pi over 4. So once again, this is negative 5 pi over 4 where we stop as the positive side. So that's going to be the positive side. Well, we got a positive 4, so we're going to count out 1, 2, 3, 4. Okay, does that make sense? Okay. The next one we're going to look at, we probably could use these graphs. We just had to make them a little bit bigger. So I guess we could do that. So let's take this one and let's make it a little bit bigger. So we've got how many circles? 1, 2, 3, 4. The next one says 6, so we've got to add 2 more circles. That would be 5, and then here's 6. Okay, let's extend our lines out a little bit. All right, so the next one we're talking about is problem number 5. Problem number 5 gives us an ordered pair, a 6 comma pi over 3, no, pi over 6. 6 comma pi over 6. And it says that find another representation, another r comma theta for this dot under these given conditions. So the conditions that they give is that r has to be less than 0. So what does less than 0 mean? It means that it has to be a negative number. So r's got to be negative on the new one. And then it says that theta has to be between 0 and 2 pi. Okay, so within one complete rotation, somewhere within there. So we're going to plot 6 pi over 6 first. So we're going to go to pi over 6. So this is pi over 6, and we're going to count out 6. So we've got 1, 2, 3, 4, 5, 6. So there would be my dot. So now we have to come up with some way of renaming this point right here where the r is negative and the theta is somewhere between 0 to 2 pi, meaning it's a positive number. Okay, so first, how can we get a r being negative? Well, we would have to come across from this side being the positive side of something, right? So this, we'd have to come out here. If I make this the positive side, then backing it off would make it the negative then, right? So I want it to be negative 6, but I have to decide what is that going to be over here on this side. Okay, well, if this is going to be coming across, then we're looking at what is this thing right here. All right, so when you count it off, then you got 1, 2, 3, 4, 5, 6, 7 pi over 6, right? So that's 7 pi over 6. That's between 0 and 2 pi, so that's good. And to get to the dot, we'd have to go backwards in the negative. So our new number is negative 6 comma 7 pi over 6. So it's negative and it's within 0 and to 2 pi. So that's all they're asking for is another name for this dot. Now we could come up with all kinds of different names, but they're giving us conditions on it in this case. Now number 6 is the same kind of problem. The only difference is their restrictions. They say r is greater than 0. So r is greater than 0, then we'd make it r being positive. And then it says negative 2 pi to 0, so it means that theta's got to be negative. So on number 6, you're going to have r being positive and theta being negative. Okay? So I'm going to move this out of the way for a minute. We might bring another one back here in just a bit. So number 7 says you've got a polar coordinate. So number 7 you have negative 3 comma 2 pi over 3. So it says polar coordinates of the point are given. So this is r and this is theta, right? Because it's a polar coordinate. Find the rectangular coordinates of the same point. So we're trying to convert from polar to rectangular. So this is polar. We're trying to get rectangular. Now, to be rectangular, it has to have what? X's and Y's, right? Not r's and thetas. So if you go back to your notes, we had some conversion formulas. We had one that said x equals r cosine theta. And we had one that said y equals r sine theta, right? So that would give us an x and a y, which we wanted. That's what we want. They give us the r and the theta, so all we have to do is plug in r and theta, and that'll give me my x and my y. So x is equal to r cosine theta, so that would be negative 3 cosine 2 pi over 3. So that's going to give me the first. And then the y is going to come from taking negative 3, which is r sine theta. Our theta is going to be 2 pi over 3 again. So again, you're using your unit circle. You should know these in your heads. So you're going to look at a unit circle picture. And what is 2 pi over 3? So we know 2 pi over 3 is going to be over here. So that's going to drop down, and that's going to tell me x equals negative 3 times what for cosine 2 pi over 3? Cosine is going to be what? Negative 1/2, right? So this would be negative 1/2. So negative times negative is going to make this be positive. So we get x equals, put this over 1, multiply across, I get 3 over 2. So there's my x. To do my y, sine 2 pi over 3, sine is going upwards, so it's positive. So we're going to get a positive, so I have y equals negative 3 times a positive what? Square root of 3 over 2. Again, you need to know your unit circles, so this point right here would have been negative 1/2 comma square root of 3 over 2. So the x is the cosine and the y was the sine, right? So I put this over 1 and I get y to be negative 3 square roots of 3 over 2. Now we want to put it together as an ordered pair, so x, y, 3/2 comma negative 3 square roots of 3 over 2. So this would be my answer for number 7. Okay, number 8 and number 9 are worked the same way as number 7, so we won't take time to do 8 and 9. You can follow the same steps that you followed here with your r cosine theta. So starting with number 10. Number 10 says that we want to find the rectangular point is given and we want to find the polar coordinate this time. And it says theta needs to be in radians. So it gives us the point 5 square roots of 3 comma 5. And 5 square roots of 3 comma 5 is going to be our x comma y. And so that means we're looking for, this is rectangular, we're looking for the polar, the r comma theta. Okay, so x and y is given to you this time, and now you're looking for the r theta. Now if you think back on the conversion formulas there, we had the one that said r squared equals x squared plus y squared. And we also had one that says r equals the square root of x squared plus y squared. Okay, now we know r is always positive. So, well, in this case, depending upon which way it's on the axis. But now we're going to have also theta. We said theta was going to be inverse tangent of y over x. Okay? So these are my conversion formulas like my ones up above were. So up above we had x and y's becoming from r's and thetas. Now we're having r's and thetas becoming from x's and y's. Okay? So we're going to plug in the things that we need to have to get r and theta. So we can use this one. So we're going to have r equals the square root of 5 square roots of 3 squared. That would be x, right? Plus y squared would be 5 squared. Okay, that's going to give us r. And theta is going to come from inverse tangent of y, which is 5, over x, which is 5 square roots of 3. So we're going to do this one first. 5 squared is 25. 3 square root of 3 squared is 3. 25 times 3 is going to give me 75, right? Because we got 15 and 3, right? So 75, and then we've got 5 squared is 25. So the square root of 75 plus 25 is going to give me r equals square root of 100, which is 10. So now we've got our r. Now we've got to come up with our theta. So r equals 10. So we're going to rewrite this because I want you to see it and think unit circles. So we're going to rewrite it as tangent theta equals, the 5's are going to cancel out, and I've got 1 over square root of 3. Okay? So now we have to think in terms of where am I for 5 square roots of 3 comma 3? Where am I in the coordinate plane? Well, in this particular coordinate plane, both of them are positive, so that means that this would be in what? Quadrant 1, right? So we've got to come up with a polar coordinate that takes us to that same dot, so we've got to pick something that's also in quadrant 1, right? So the reason why I say that is tangent can be positive in quadrant 1 and in quadrant 3, right? So we're not going to use the 3 when we're going to use the 1. So what I do on this one is I think backwards. So I got tangent theta equals, this 1 came from having a 1/2, and the square root of 3 came from square root of 3 over 2. So that would give us 1, if I multiply by the reciprocal, would give us 1 over square root of 3. But tangent is sine theta over cosine theta. So basically what we're saying, we're looking for the ordered pair that's 1/2 comma, nope, which is square root of 3 over 2 comma, let's try that again. We're looking for where cosine and sine. So we're looking for square root of 3 over 2 comma 1/2. So that's what we're looking for in the unit circle, to find this particular theta. So if you look on your unit circle, what particular theta gives me square root of 3 over 2, 1/2. Okay, pi over 6, good. So pi over 6 would be our theta, and 10 would be our r. So our ordered pair is r comma theta, 10 pi over 6. So you okay with this one? Except for that little scribbled part. All right, we're going to go ahead and do number 11, because number 11 is this same kind of problem, but we're still going to try it so that you can see how to do it. Number 11 gives us the ordered pair 4 comma negative 4, and this is going to be number 11. So again, this is rectangular, and we're converting that to polar. Okay, so we're trying to get an r comma theta that goes with this x comma y. So we know our formulas from before. R is equal to the square root of x squared plus y squared. And we know that tangent theta equals y over x. So r is going to be the square root of 4 squared plus negative 4 squared. 4 squared is 16. Negative 4 squared would be negative times negative is positive 16 too. So we get the square root of 32. But the square root of 32 can be rewritten as the square root of 16 times 2. So again, this is still r. Square root of 16 would come out as a 4. So we have 4 square roots of 2, and that's going to be our r. Now we're going to come over here. Tangent theta is y over x, so I get negative 4 over 4. So where is 4, negative 4 as far as references in the plane? Is it going to be what quadrant? So we know 4 to the right and 4 down is going to put us in quadrant 4. 4 to the right and 4 down, right? Quadrant 4. So now I'm looking over here and I'm saying tangent theta. So tangent theta equals negative 4 divided by 4 gives me a negative 1. So that would be sine over cosine again, because tangent is sine over cosine. So we know we're in quadrant 4. Well, we know tangent is negative in quadrant 4, so that makes sense. But we're looking for the place where sine and cosine are going to be the same number. It's not 1, but it's going to be the same number that makes the division to be 1, right? So what is the 1 and 4th quadrant where they're both the same? Okay, 7 pi over 4, good. Now, someone else said that it could be negative pi over 4. Okay, that's another way of writing 7 pi over 4. So my r and my theta is going to be 4 square roots of 2, comma, 7 pi over 4. So that was number 11. Okay, the next one we're going to look at is number 12. Number 12 says, convert the rectangular equation to a polar equation that expresses r in terms of theta. So basically they're saying x squared plus y squared equals 25. They want you to create this and make it into an r comma theta equation. Now, we said x squared plus y squared is going to be r squared, right? So this would be x squared plus y squared equals r squared. So these two things are going to be equal to each other because x squared and y squared are equal to each other. So r squared equals 25. So I take the square root on both sides. We said r is going to be positive, so we're going to get r equals a positive 5. So this would be my polar graph. Now, we did this before with r equals 3. So to graph r equals 5 was that one where we graphed, we had 1, 2, 3, 4, 5. I should have used one of those other graphs. But we said that with r equals 5, you don't care about the theta at this point. You just want to plot the r equals 5. So we would plot 5, 5, 5, 5, 5, all the way around. All these would be 5, right, on this concentric circle. So then when I did that, then my actual graph would be this circle, right? Now it kind of makes sense because over here, x squared plus y squared equals 25 is also a circle. This would be the center at 0, 0, and the radius would be 5. So we would count out 1, 2, 3, 4, 5, and we would draw a circle. So polar, rectangular. Okay, for number 12. All right, so that one was pretty easy. So now let's look at number 13. Tell ourselves it's going to be just as easy, right? So number 13 says we have 8x minus 9y plus 12 equals 0. So 8x plus 9y plus 12 equals 0. Then again, we know x equals r cosine theta, and we know y equals r sine theta, right? So what are we going to do? We have an x and we have a y, and we're trying to get them in terms of r's and thetas. So what do? I take r cosine theta and I plug it in for x, and I take r sine theta and I plug it in for y. So what's that going to look like? 8, and then we're plugging in r cosine theta for the x, so r cosine theta, and then we've got minus 9 times y, which is r sine theta, and we still have plus 12 equals 0. Now, we have a special way we like leaving our things in rectangular form. Well, there's also the same with polar. So polar likes to leave it solved for r. So we're going to have to change whatever we need to do to fix this where we get r on the outside. So the first thing I'm going to do is take the 12 over. So I'm going to leave 8r cosine theta minus 9r sine theta, but I'm going to subtract the 12 over. So I get equals negative 12. Now the reason why I did that is because 12 doesn't have an r in it. See how both of these now have an r in it? So we can take an r out. So if I distribute an r out, this gives me 8 cosine theta, because I took the r out. And then here's going to be minus 9 sine theta, because I took the r out. Now we're solving for r, so this is multiplied by r. So what do we do to get rid of this, to get it to the other side? Opposite of multiplication would be the divide. So we're going to divide by 8 cosine theta minus 9 sine theta, this whole parentheses. We got, got to do it on both sides. So this is going to cancel with this, and we're left with r equals negative 12 over 8 cosine theta minus 9 sine theta. And this would be my equation. So everybody okay on 13? All right, next one is 14. Now, on number 14, they're asking you to convert from polar to rectangular now. So the first one was rectangular to polar. Now we're going polar to rectangular. So they give us r equals 9 cosine theta. And then they give us plus 6 sine theta. Okay, so that's the one that's given to you. Now, we said before x equals r cosine theta and y equals r sine theta, okay? But in this case, we don't have an r, okay? So what we're going to have to do is we're going to have to make ourselves have an r. So as long as I do the same thing to both sides of an equation, it's still going to be equivalent. So I'm going to take my equation, which was this equation, and I'm going to multiply both sides by r. As long as I do the same thing on both sides of an equation, it's still equivalent. So r times r is going to give me r squared. So now this r, we're going to come in and write it in the middle. So 9r cosine theta, because I'm multiplying it times the r cosine theta, plus, same thing on this side, 6r sine theta. Do you see what I did? As long as you multiply by the same thing on both sides, it's still going to be equivalent. But now, what is this piece? And what is this piece? R squared, we know, is x squared plus y squared. So I can plug that in for r squared. So this is going to be 9x plus 6y. And then this would be my answer. So we're okay on number 14? Now, number 15 is just straightforward. You're given, for 15, you're given r cosine theta equals 9. Okay, so r cosine theta is going to give you what? If you look up here, r cosine theta is equal to what? R cosine theta is equal to what? So we can replace r cosine theta with x. So this is just going to say x equals 9. Now, what does this rectangular graph like this look like? X equals is going to do what? It's going to be a what kind of line? If I were to graph x equals 9, how would I graph it? Well, we would ask ourselves, which axis do I have? X. Where am I going to cut it is 9. So I'm going to the x-axis and I'm cutting it at 9. So this would be 9 down here. So x equals are always a vertical line. If I gave you y equals 3, then that would be a horizontal line at 1, 2, 3. Okay, so this is a line, vertical line. Okay, the next one is just a repeat basically of number 13. So I'm going to let you guys figure that one out on your own. And number 17, I guess we can look at 17. It's pretty easy too. Number 17 says, write an equivalent equation in rectangular coordinates. So r parentheses cosine theta minus sine theta equals 6. Now, what are we going to do first with that r? We're going to distribute the r in to both of those things. So we get r cosine theta minus r sine theta equals 6. Now, this should be familiar to you now, right? What is r cosine theta? What is r sine theta? So we get x minus y equals 6. And there's my answer. So try not to overthink it. Sometimes if we overthink it, then it doesn't help. Okay, so we had that formula sheet to where how things looked. So let me see if I can find one here real quick. Be right back. Okay, so this is one that was online that you can look up underneath your homework assignment. So we talked about this a little bit where we said that we wanted you to be able to see the equations and be able to associate it with what its picture is supposed to be. Okay, we said that this one was going to be a circle. This one is the sine because it's on the y-axis. This one is cosine because it's on the x-axis. We have this loopy-loop and this dimple, if you will, and then the different types of rose leaves, and then the lemma skates that have the infinity-looking sign. Okay, so this would be the cosine one, and this would be the sine one on the diagonal. Now, the number of petals is determined by whether even or odd for the n. If n is odd, so see like this one has a cosine 3 theta, it only has 3 petals. This one, though, has a cosine 2 theta. So if it's an even n, if n is an even number, then we double the petals. So see right here, n is 4, so we have 8 petals. This one was 5, so we just have 5 petals. So that's how we determine. And also we said the a was the length of the petal. Okay? So you have this to look at with you while you're taking the test. So the next one we're looking at is number 18. It's multiple choice. 18 and 19 are both multiple choice. Now, obviously, I've got the answer circled already, but hopefully you can see this without doing that. This one we said was going to be like the circle that was on the y-axis, right? So that's why we get this 2 sine theta, because the sine would be on the y-axis. Okay, here we've got a rose curve. We got 1, 2, 3, 4, 5, 6, 7, 8 petals. And they're all, if you count out, 1, 2, 3, 4 in length. So 4 in length, and the counting 8 petals would give us a 4 as the end. So 4 cosine 4 theta. Okay, so there's the two things that are multiple choice, so that way you can select them pretty easily. So the next one is our job is to graph, and I'm going to get you started on them. I'm not going to do the whole thing with them because the video would be way too long. But I'm going to get you started on them. So we're looking at number 20 now. 20 is r equals 6 sine theta. So we go back to our picture chart again, and we decide what is it going to look like. Well, r sine theta, or in this case, a sine theta, is going to be this circle that's up on the y-axis. But we've got to get our circle to be up on the y-axis. So we're going to make a r theta chart. Okay, so our theta chart, we're going to put in some things for theta because theta is going to be our input. So the things that I chose to put in my theta was pi over 3. You could use all the ones that you know. Pi over 2, 2 pi over 3, pi over 4, and pi over 6. So we're plugging those things in for theta, right? So the first one, r equals 6 sine pi over 3. So if you look at your unit circle, you know what pi over 3 is, and you know what the sine of pi over 3 is. So let's look at the unit circle. So here's a unit circle. Pi over 3 is here. So the sine is going to be what? Square root of 3 over 2, right? So 6 times square root of 3 over 2. So this 2's cancel with the 6, and I get 3 square roots of 3. So that's what this first one's going to be, 3 square roots of 3. Now, since we're graphing it, though, we want to make sure we have a decimal approximation. So that's where your calculator can come in handy. 3 square roots of 3 gives us approximately 5.2. Okay, so then you go all the way down. We go to the next one. We got r equals 6 sine pi over 2. Now you know sine pi over 2 is up here, right? So pi over 2 is going to give us 0, 1. So sine of pi over 2 is going to give us 1, right? The y value. So if this is 1, 6 times 1 gives me 6. Now that was good though, because we knew that this was going to go up 6. So this pi over 2 gives us our up 6. So that's good. So then we're going to do 2 pi over 3. Now, when you think of symmetry, if pi over 3 is on this side and 2 pi over 3 is on the other side, then these two are probably going to be the same thing on our plugging in. So when we plug it in, we do get the same thing, so we get 5.2 again. Pi over 4, I'm just going to tell you what you get, 3 square roots of 2, and that comes out to be 4.2. And then we have pi over 6 comes out to be 3. Plugging them in, right? So now we're going to go get our graph paper. And the biggest number we have is a 6, so I think we just need to add 2 again like we did last time. So we got 1, 2, 3, 4, 5. Now on the test, they actually give you the graphs too. So you won't have to do this on the test. Okay, like I said, extend these lines out. All right, so the first one we said we had was pi over 3. And we said that was going to go out 5.2. So pi over 3 going out 5.2. Here's my pi over 3. So I count out 1, 2, 3, 4, 5.3, 5.2. My next one is square root of 2 and 6. So pi over 2 gives me here, and 6 would be 1, 2, 3, 4, 5, 6. And then 2 pi over 3 is this next one. So 2 pi over 3 is going to be 1, 2, 3, 4, 5.2 again. Now obviously ours is going to be a little skewed because we have not a very accurate graph in the first place. Pi over 4, 4.2. So here's pi over 4. So we're going 1, 2, 3, 4.2. And then pi over 6, we're going out 3. So pi over 6 is here. So 1, 2, 3. And then the rest of these, since we see how this one was symmetry, the rest of them are going to be symmetry on the other side. So we're going to do the same thing on the other side for each of them. 1, 2, 3. And then we just circle the circle in. Hopefully it looks a little bit like a circle. Now, if you want to color it in or anything like that to make it easier to see, you can, get a red pen and just color it inside to make it where it's easier to see. Or you can get a felt tip or whatever you want to use to color it in. So we have a circle. All right, so we have number 21 is going to be the same kind of thing where it's going to be a graph where we have to plot points. So on number 21, we're going to have an equation. I'm going to help you to find out what they're supposed to look like. And then I'm going to have you guys do the graphing of them. So 21 is a r equals 3 sine 2 theta. R equals 3 sine 2 theta. This is going to be an A, and this is going to be an n theta. So we've got R equals A sine n theta. So we look on our chart. So which one on the chart has this equation? R equals A sine n theta. Okay, does anybody see it? So it's going to be a rose curve, right? R equals A sine n theta. Now, once we know it's a rose curve by knowing what the shape of it is, then we're going to ask ourselves, where do we go from here? So what is this thing right here? This A stands for how long the leaf is. So this is the length. And this tells us how many. So it's 3 in length. And then if it's even, we double it, right? So it's going to have 4 petals. So that makes sense? Okay. The next one, number 22, it says R equals 1 minus sine theta. Okay, now, this is R equals 1 minus 1 sine theta. So the only one that has something like that is your lemicons. So the lemicons say if A and B are the same, then it's going to be that cardioid shape. So it's either going to look like coming around like this for the top, or it could come around the same thing and do the same thing around the bottom. So you got to just see what it's going to look like. Okay, since A and B, this would be my A and my B are the same number. Okay, the next one is 23. 23, you have R squared equals 9 cosine 2 theta. Now, you know that 9 is also a square, so this is R squared equals A squared cosine n theta. So we look on our picture graph. The only one that's A squared or R squared is going to be the lemniscate. This has got a cosine in the middle, so is it going to be horizontal or is it going to be diagonal? It's going to be horizontal. So you know it's got to be a horizontal one. And I think that's the only ones that are graphing, so let's see. Yes. Okay, so the next section on here is the parametric equations. So we're finished with our graphing, so we're going to take this page away. So now we have, it says the table of values, use the table of values to graph the plane curve defined by the following parametric equations. Okay, and then it says find a rectangular curve, rectangular equation for the curve. So the two equations they give us are, this is number 24, x equals 2t minus 1, and y equals t squared plus 1, and t goes from -4 to 4. Okay? So when we did these in class, we said the first thing we're going to do is make a chart. So we're going to build a chart. And that last one's going to be a little wider because that's where the ordered pair goes. So we've got t, x, y, and x comma y. So now, what goes inside this? Now, make this look like a plus instead of an R. Okay. So we know we got to go low to high. So we're starting with the -4, and then we're going all the way up to +4. So -4, -3, -2, -1, 0, 1, 2, 3, 4. So now we have to decide what we've got. We've got t going into x. So -4 is going to go into here. So 2 times -4 gives me -8. -8 minus 1 gives me a -9. So there's -9. And then we put the y in for the y. So -4 times -4 gives me a +16 plus 1 is 17. So this is 17. So now I have -9, 17. So I go down and do all that all the way down. So I'm just going to go ahead and write them in to save time. So I get -7, -5, -3, -1, 1, 3, 5, and 7. So that's all the x's. And then the y's go 17, 10, 5, 2, 1, 2, 5, 10, 17. Now this right here is just the order of pairs. So -7, 10, -5, 5, -3, 2, -1, 1, 1, 2, 3, 5, 5, 10, and 7, 17. Okay? So we're going to graph it on the graph. They give us a graph in the book. On the paper it gives you a graph, but we're going to have our own graph. So we're going to make our graph go just like they did. So it goes 5, 10, 15, 20, 25. So 5, 10, 15, 20, 25. So there's 25. We're going to go up the same way. 5, 10, 15, 20, 25. Okay, and then same thing here. 5, 10, 15, 20, 25. And 5, 10, 15, 20, 25. Okay, so that's the way they have it marked on the one in the review. So now we're just going to plot these points. So -9, 17 is going to give us what? So -9, each of these is 5, right? So -9 would be going to the left, 17 would be going up. So 5, 10, 15, 16, 17. So it would be approximately right there. Because this is 5, 10. 10 would be close to -9. Okay, -7, 10. So 5, 10. This would be 5. -7, 10 would be approximately there. And obviously our graph is not going to be real accurate just for the fact that we've got it handwritten like this. Next one is -5, -5. So -5, +5, I'm sorry. And then we've got -3, 2. So -3, 2 would be about there. -1, 1. And then 1, 2. So they're kind of getting all jarbled down here at the bottom, right? And we've got 3, 5. So this would be 3, 5. And then 5, 10. And 7, 17. So about here. So when we draw it in, it sort of looks like a parabola. Now we're going to start by arrowing going off this direction because we said we were going to go low to high. So that would be low to high going off in this direction. Okay, so the next part that it asks us to do, it says, then find a rectangular equation for the curve. So this curve, we know by looking at it, it's going to be a picture of a what? Picture of a parabola, right? So we're going to see if we can come up with the picture of the parabola. So we eliminate the parameter. And the right parameter is my t, right? So we're trying to eliminate t. So which one of these equations would be the easiest equation to solve for t? Yes. Okay, any ideas? All right. So what we're going to do is we're going to pick one and we're going to solve for t. So I'm going to pick this one right here. Okay? So that's going to give me x equals 2t minus 1. I'm solving for t now, right? So if I solve for t, I add 1 to both sides first. So I get x plus 1 equals 2t. And then I divide by 2 on both sides. So this gives me t equals x plus 1 over 2. But now, what do I do with this t? T equals. I plug it back into the one that's covered up by the screen, so we'll pull it down. We're plugging it in for t. So that's the t we're plugging it in for. So this becomes down here, y equals, this is going to be x plus 1 over 2 squared plus 1. Because all you're doing is plugging in for t, right? The x plus 1 over 2, and you're squaring it and adding 1. So now, realistically, you have it, but let's take one more step. This is going to be y equals, squaring the top is going to give me x plus 1 squared, but then I'm going to bring out the 2, which would give me 1/4 coming out, right? Because the 2's in the denominator. And then you still have the plus 1. So we've got a form of a parabola here. The form of the parabola is going to be y equals 1/4 is the a, x minus h squared plus k. So that's a form of a parabola that you guys probably had in Algebra 2. So that's okay to leave it like this. That would be an equation in rectangular form. Now, you could also FOIL it out and divide by 4 and do all that stuff too. Okay? So we're going to do one more. We're going to do number 26, and I think we're going to call it a night on that one. So we'll do number 26 or 27. Actually, I think what we've done is basically the same thing as what 26 and 27 are asking us to do. So they're just not having us do the first part, they're just having us to eliminate the parameters. So I think we're going to stop there. If you have any questions, then please let me know. That was the review for Chapter 8. Thank you very much.